Hello everyone and welcome to Organic Chemistry. Today I'll give a presentation on alkenes. What are alkenes? Alkenes are compounds that contain carbon-carbon double bond. So for example, the simplest example for alkene has 2 carbons, and remember each carbon must have 4 bonds. So we have 1, 2, and then we're remaining with 2 more, so we add hydrogens. So hydrogen, and here hydrogen and hydrogen. So each carbon has a valence of 4. So that's the simplest alkene. And because it has 2 carbons, alkane with 2 carbons is called ethane. For an alkene, you drop the ane and change that to ene. So the name for an alkene is, you change that last part, becomes ene, alkene. So with 2 carbons, its name now will be ethene. Remember, we drop the ane and change that to ene. This is an ethene. Next, hybridization. Hybridization basically refers to the type of orbitals that are used in the molecule. So if you look at an alkene, HC double bond CH, that's the simplest alkene. The carbon here is bonded to 3 things, 1, 2, and 3. So when carbon is bonded to 3 things, that gives what's called sp2 hybrid orbitals. So sp2 hybridized. So actually both carbons, even this other carbon, is sp2 hybridized. For something to be an sp2 hybridized, it will mean that its geometry is flat, so we say planar, and the bond angle is 120 degrees. So that means this angle here and this angle is 120 degrees and contains a double bond. So has a double bond. So if a carbon has 1 double bond, it will be an sp2 hybridized. So alkene carbons, the double bond carbon is sp2 hybridized. Just as a quick example or a quick review, if you have something that looks like this, here you will see that this is sp2, this is sp2, but these other 2, so that and that, are sp3 hybridized because you actually have 4 bonds on each carbon, and we will look at that later. Okay, next, skeletal structure. Now this is where we use lines instead of carbons to draw organic molecules. So for example, if you have a CH3, CH2, CH2, and then CH, and then double bond carbon, H and H, you'll see that we have carbon number 1, 2, 3, 4, and 5 carbons. Next, we draw the skeletal structure, and here we only use lines. So carbon number 5, so that end means it's 1 carbon, and then each corner will be a carbon, so that's carbon number 4. So carbon number 5, and then that corner will be carbon number 4, this corner will be carbon number 3, then that carbon corner is carbon number 2. You'll see that carbon number 2 has a double bond to carbon number 1, so we put double bond like that. So that is the skeletal structure.